Hello, in this video I'm going to solve problems in homework number 11. So consider the curve with the following equation. The tangent to the curve at this point, 4 and minus 4, meets the y-axis at point P. The sum of the coordinates of P is equal to what? We are supposed to find that. Okay, so you can see that this is a very standard problem. It's related to the tangent to a given curve at a given point on the curve. And why this point is really on the curve, you can check it yourself. You can replace x with 4. If this is correct, the answer to y should be minus 4. But if I replace x with 4, I will have this. But 16 over 4 is 4, minus 4 times the square root of 4 is 2, so it becomes 4 minus 8, which is indeed minus 4. So yes, everything seems fine. Okay, so let us find an equation for the tangent to this curve at this point. And this is a very standard problem, so you have to differentiate the function. But this function is still not ready for differentiation, so the first thing that I will do is I make it ready. So instead of writing 16 over x, I can bring x up and make the exponent negative, and minus 4 instead of the square root of x, I put x to the power of 1/2. And now everything is ready, I start differentiation. For differentiating this one, minus 1 goes down, so this becomes minus 16, and the power, the exponent, becomes 1 unit less, which is minus 2. So it becomes minus 16 x to power minus 2. And minus 4, the next one, 1/2 goes down, so it becomes times 1/2 x to the power of 1/2 minus 1. 1/2 minus 1 is minus 1/2. And I prefer to simplify this as much as I can, so I can write minus 16 and I write x to the power of minus 2 in the denominator with positive exponent 2. And here 4 and 2 are simplified, so this is just positive 2, and I bring it down, make it with positive exponent, so it becomes minus 2 x to the power of 1/2. But x to power 1/2 is actually the square root of x, so it is preferable to write it in that form. Okay, so now this is the derivative. What I will do, I want to calculate k value of the tangent line, so be careful. What you have calculated so far is the derivative, not the slope. You have to replace the x coordinate, the x value in the function, in the derivative of the function, with the x coordinate of the point of tangency. That will give you the k value. So k value is y prime of 4. So this becomes minus 16 over 4 to the power of 2, and then minus 2 square root of 4. Okay, 4 to power 2 is 16, 16 over 16 is 1, I have a minus sign there, so it becomes minus 1, and the square root of 4 is 2, so it becomes minus 2 over 2, which is also another 1. So this becomes minus 2. So the k value of the tangent line is minus 2. Okay, so the k value is given now. We know it. We also know the point of tangency. So I will use this formula. So we can solve it in two different ways. I would prefer to solve it from this formula. Y minus y naught equals to k x minus x naught. Here in this formula, x naught and y naught are coordinates of any point on the line. Of course, in this case, we do not have access to other points except the point of tangency. So I will use x naught. I will use 4 as x naught, and I will use minus 4 and y naught. And this one, minus 2, is my k value. So this is very straightforward. Y minus 4, k is minus 2, and x minus 4. And of course, I will simplify it. Minus 4 plus 4. And then I multiply the minus 2 in, so it becomes minus 2x plus 8. And then I move 4 to the other side, so it becomes minus 2x plus 4. And this is the answer to the tangent line. Okay, But for the tangent line, I can do another way. So let me write it with a different color. So this is method 2 for finding the tangent line. So I would say that equation of the tangent line is of this form. We got k is -2, so y becomes -2x plus m. But now I know that this line is supposed to pass through this point, so it means that the coordinates of this point will satisfy this line, the equation of this line. So instead of y I put -4, instead of x I put 4, so it becomes -2 times 4 plus m. Then I find m, so it's -4 equals to -8 plus m. I move -8 to the other side, it becomes +8 minus 4 is 4. Okay, so this will be your m. But again, if I go back and replace m with this given number, then the answer will be exactly the same. So I will get y equals to -2x plus 4. So you see that in both ways you will find this. Okay, my preference is to use the first method. Okay, but the problem is asking about something else. The problem tells you that this tangent meets the y-axis at point P. We want to find the sum of the coordinates of point P. Okay, so if you have a point P on the y-axis, for example, so you know that the coordinates of this point, the x-coordinate is of course 0 because it is on the y-axis, and I want to find the y-coordinate. Okay, so this means that if the y-coordinate, I call it beta. Okay, so let me write it like this. I would say let P be the intersection point of this line with the y-axis. Because it is the y-axis, so the x-coordinate is 0, y-coordinate is not known, so I call it beta. Okay, and then what happens, P is on the tangent line. Thus, the coordinates of the point will satisfy the equation of the line. So it means that instead of y, I put beta, and instead of x, I put 0. So beta becomes -2 times 0 plus 4. So beta is just simply 4. Or if you understand that m value is the y-intercept, you could immediately understand that beta is 4. So it doesn't matter, okay? But they are asking about the sum of the coordinates, which is of course 4, because one coordinate, the x-coordinate is 0, the y-coordinate is beta, which we got 4. So the answer to this problem is simply 4, and 4 is the number that you have to type here. Okay, so now let us go to the next problem. Okay, number 2. If the straight line y equals to kx plus 14 is a tangent to the curve y equals to 12 over x plus 2, so you have to interpret this as 12 over x plus 2. Be careful, it is not 12 over x plus 2. Okay? If they wanted to have that, they have to put a pair of brackets around that. Okay, at the point P. So we know that this line is tangent to this curve at a point P. We want to again find the sum of the coordinates of the point T. I will solve this in two different ways. One using the notion of derivative, and one without using derivative at all. Okay, so let me write method 1 using derivative. Okay, so I don't know the coordinates of the point T. I would say that let T be alpha and beta. Okay, we know that the derivative of the function calculated at the x coordinate of the point of tangency is equal to the k value of the tangent line, which is this k value here. So it means that if you differentiate your function, replace every x in your derivative with alpha, that expression will become equal to k. Okay, so it means that the first thing that I need to do is to calculate the derivative. So let me prepare it for differentiation, which is extremely simple. I bring x up, so it becomes 12x to the power of minus 1 plus 2. Then what I will do, I differentiate. Minus 1 goes down, so it becomes minus 12. X to the power of minus 1 minus 1, which is minus 2. And the derivative of 2 is simply 0. I prefer to write it in positive exponents, so y prime becomes minus 12. I bring x to the power of minus 2 down, so it becomes this. Now, if I ask you what is the k value, the k value is simply if I replace x with the x coordinate of the point of tangency. So it becomes minus 2 or 12 over alpha squared. This is one relation. But of course, you know that there are two unknowns here, one alpha and one k, so we cannot solve the problem using one piece of information. In total, how many unknowns are there? Alpha, beta, and k. So I need three equations. One equation is, of course, this one you see. The other equation is that the point of tangency, if you have any curve, and this is the tangent line and this is the tangency point, so you see the tangency point is on the graph as well as the tangent line. So it means that the coordinates of the point of tangency not only satisfies the equation of the function, but also the equation of the tangent line. So I would write t, alpha and beta, is on y equals to 12 over x plus 2. Then it means that if I replace y with beta and if I replace x with alpha, this equation should hold. So this is my second equation. Okay, so let me put a pair of brackets around it. And then again, t alpha and beta is on the line as well, is on y equals to kx plus 14. Yes, so from here I can conclude that beta is k alpha plus 14. So what I did, I replace y with beta and replace x with alpha, I get this equation. Now if I ask you how many equations we have, you see that we have three equations, and how many unknowns we have three unknowns. But what the problem demands is the sum of the coordinates of t. So in principle, the problem is not asking about k, the problem is asking about alpha and beta. After finding them, we have to add them up. So it means that I have to get rid of k in some way. And that is also simple, because in this equation, instead of k, I just put this expression, and then k is eliminated from my problem. So let me continue. Beta becomes equal to k is minus 12 over alpha squared multiplied by alpha plus 14. But this alpha here will cancel one of these alphas. One alpha is left in the denominator. So this means beta is minus 12 over alpha plus 14. Okay, but now look, there is a very nice relation. Beta as on the one hand is this expression, beta on the other hand is this expression. So it means that they have to be equal. So this means that 12 over alpha plus 2 should be equal to minus 12 over alpha plus 14. Okay, what can I do here? I want to get rid of fractions, so I multiply everything by alpha. The left hand side becomes 12 plus 2 alpha. The right hand side becomes minus 12 plus 14 alpha. Okay, so what happens now? This, I move 14 alpha to the left, so 2 alpha minus 14 alpha is equal to minus 12, and I move 12 to the right hand side, so also becomes minus 12. Now the left hand side is minus 12 alpha, the right hand side is minus 24. I divide by minus 12, alpha becomes 2. Okay, if alpha becomes 2, I put it in this equation and I get my beta. Okay, so beta becomes 12 over 2 plus 2, which is 6 plus 2, which is 8. So beta is 8. But the problem is asking you about the sum of the coordinates of alpha and beta. So it becomes 2 plus 8, which is 10. So the answer to the problem is simply 10. Of course, if they also ask you about the k value, you can put alpha here. It becomes minus 12 over 4, which is minus 3. So the slope is also minus 3, but the problem hasn't demanded that from us, so we don't need to do that. Okay, so this is the solution of the problem using the notion of derivative. But now let us solve the problem without the notion of derivative. Okay, so if you remember in the lesson I told you that if you have a function and if you have a line, the line might cut your function in more than one point, and that is called a secant. The function might not even cut your graph or function, so it has nothing to do with your function, but in some intermediate way the function can just intersect your curve at one single point. Okay, so this means that this is exactly the case that we are interested in. The line becomes tangent to the curve. Okay, so I want to use this idea. So method 2, without using derivative. Okay, so the problem is the solution is based on the intersection point between this line and this curve. Okay, so in principle I want to find the intersection point between the line and the curve. So you know what to do. You need to set up a system. One equation of the system is the equation of the curve, and another equation of the system is the equation of the line, and then you look for the intersection point. But be careful. The point is not to solve and find the intersection point. Of course we want to find t is the intersection point, but we also want to force the system to have one single solution. Okay, so let me explain what do I mean by that. So first of all, pretend that you want to find the intersection point. So what do? You equate y's. Yes, so what do you write? You write kx plus 14 is equal to 12 over x plus 2, and then you multiply everything by x, so it becomes kx squared plus 14x equals to 12 plus 2x. And then because this is a quadratic equation, you move everything to the left, so it becomes kx squared plus 14x minus 2x becomes 12x, and then 12 to the left becomes minus 12 equals to 0. Of course, this is a quadratic equation. You know, depending on the discriminant of the quadratic equation, if the discriminant, which I call it d, is positive, I have two solutions. If d is 0, I have one solution. If d is negative, I do not have any solutions, 0 solutions. But here, I don't want this happen. I don't want this happen, because if this happens, means that the line does not touch my graph, does not have any intersection point with the graph, which is not wanted, because I want to have it tangent. I don't want this to happen, because in that case the line will cut the graph at 2 points and it does not become tangent. It will cut the graph. So it means that I have to force this equation to have 0 discriminant. Okay, so the discriminant of this, do you know, it is b squared minus 4ac using ABC formula. So this number is playing the role of A, this number is playing the role of B, and this number is playing the role of C. I demand the discriminant be 0. Okay, b squared is 12 to the power of 2 minus 4 times A times C. This should be equal to 0. So this means that 12 squared plus 48k equals to 0. So this means that 48k is equal to minus 12 to the power 2 is minus 144. And then when I want to find k, is minus 144 divided by 48, which is just simply minus 3. Yes, k is minus 3. Do you remember? We didn't calculate k before. The previous methods, so if you don't mind, let me go back. Do you remember? In this method, using the notion of derivative, the point of tangency is derived first, and if you want to, you can find the k value. But in this new method, k value is found first, but then if you want to find the point of tangency, what you are supposed to do, you are supposed to put this back into this equation and find x. This discriminant to be 0 guarantees that you will get only one x, not two x's. So I will do that. So I will go to this. Instead of k, I put -3 and solve the problem. So it becomes -3x squared plus 12x minus 12 equals to 0. For simplicity, I divide everything by -3. Yes? And of course you can use ABC or PQ formula, but that is a very nice pattern, a simple one. X minus 2 squared is equal to 0. So then it means that x is equal to 2. But you have to be careful. If I ask you what x equals to 2 is, you will tell me this is the x coordinate of the only intersection point between this line and this. It means that this is the x coordinate of the point of tangency. So this is the x coordinate of point T. And if I want to find the y coordinate, I take that x coordinate. If I put it here, it is possible I use -3 and x2 and then I find y, or I would say it would be much easier if I put it here. So y becomes 12 over 2 plus, 12 over 2 I should write. 12 over 2 plus 2, which is 6 plus 2 is 8. And again, the x coordinate plus the y coordinate is 2 plus 8, which is 10. So you see that you get the same answer as you did in the previous case. Okay, so let us now go to the last problem. Okay, so the next problem now, this graph is given to you. So you have a parabola here with this equation, and then you have a straight line with this equation, x plus 5, 2y equals x plus 5, and then you have two intersection points. The equation of the tangent to the parabola at B written in this form is what? Okay, so I want to find an equation for this line that I'm drawing with laser beam now, okay? So this is what we want to find. But in order to do that, I need to know the point of tangency. How can I find that? It is very simple. I find the intersection point between this line and this parabola. And then you know this is the standard way of doing it. You just solve a system. X squared minus 4x plus 7 is one of them, and the other one is 2y is equal to x plus 5. Of course, you have to equate y's. What I will do, I will replace this y with this expression. So what happens then? So it becomes 2 times x squared minus 4x plus 7 equals to x plus 5. I multiply 2 in, so it becomes 2x squared minus 8x plus 14 is equal to x plus 5. I move everything to the left because that's a quadratic equation. So 2x squared minus 9x, and then 14 minus 5 is just simply positive 9 equals to 0. I prefer to use ABC formula here. So x becomes minus b plus or minus a square root of b squared minus 4ac, yes, over 2a. So minus b becomes 9 plus or minus a square root of 9 to power 281 minus 4 times a, which is 8, times 9, which is 72, and then divided by 2 times a, which is 4. But 81 minus 72 is 9. Square root of 9 is simply 3. So it becomes 9 plus or minus 3 divided by 4. So then I will have two answers. Either x is 9 plus 3, 12, divided by 4, 3. Or x is equal to 9 minus 3, 6, divided by 4. So it becomes 3 halves. Okay, but be careful. Why Did you expect to get two answers? Yes, because even in the picture you see that I have two intersection points. So one of them has x coordinate 3, the other one has x coordinate 3/2. So which one is which? It is very clear because A is on the left hand side, so this is the x coordinate of point A, which we don't want it here because we want to draw the tangent line at point B. Okay, so this is the x coordinate of point B, sorry, and this is the x coordinates of point A. But we don't need the point A, we just work on point B. So if I ask you what are the coordinates of point B, of course the x coordinate is 3, and if you want to find the y coordinate, you take 3, put it here, find y, or you take 3, put it here, find y. The second one is simpler, so 3 plus 5, 8, divided by 2, 4. So point B has 3 and 4. Yes? Okay, now I want to find equation for the tangent line, which is extremely simple problem here because this function is very easy to even differentiate. So y is x squared minus 4x plus 7. I differentiate it, it becomes 2x minus 4, but this is not the slope yet. The slope is derived if you replace the x in derivative with the x coordinate of the point of tangency, in this case 3. So it becomes 2 times 3 minus 4, which means k value is 2. Okay, so if you don't mind, let me use the formula y minus y naught equals to k times x minus x naught. So y naught is the y coordinate of the point of tangency, 4, k we got it to be 2, and then x naught is the x coordinate of the point of tangency, which is 3. So what I will do, I will actually simplify it. So y minus 4 is equal to 2x minus 6. I move minus 4 to the other side, so it becomes 2x minus 2. Sorry. This is what you have to type in the box. Okay, so y equals to 2x minus 2. That's the answer. Okay, now the second part of the problem is that for which values of m this line does not intersect this curve. So what does it mean? It means that if this is not 5, this is m, we want to have the situation in which the system does not have any solutions. So what I will do, I will set up a new system. The first equation is as before. The second equation is this one with m. And then I want to demand that the system does not have any solutions. Okay, because we don't have enough space, let me go to the next page. But remember this. I will set up a system. The first equation is this, and the second equation I will write this plus m. Okay? Okay. So you can pretend that you just want to solve and find the intersection point, exactly as before. Instead of this y, I put this expression in. So what happens? It becomes 2 times x squared minus 4x plus 7 equals to x plus m. I open up the left hand side by multiplying 2 in, and then I move these terms to the left. Minus x minus m equals to 0. Then I organize it. So I would write 2x squared. Then I have minus 8x minus x, which is minus 9x. And the other one is 14 minus m. If you don't mind, let me put a pair of brackets around that, equals to 0. So be careful. If you solve this, this is supposedly the equation in which by solving it you can find the x coordinates of the intersection points. But the problem asks you to do something that there is no intersection points. So again, this is a quadratic equation. You want to force it not to have any solutions. So it means that the discriminant of this should be negative. And this is A, this is B, and now this is C. And the discriminant is b squared minus 4ac should be negative. That's it. So b squared is minus 9 squared minus 4 times a times 14 minus m. This should be negative. Minus 9 to power 2 is 81. Minus 4 times 2 is minus 8 times 14 minus m should be less than 0. So I multiply 8 in, so it becomes 81 minus 8 times 10 is 80, 8 times 4, 32. So it's minus 112 and then plus 8m is less than 0. 81 minus 112 is 31 plus 8m should be less than 0. And this is inequality, yes? You have to solve this inequality as you learned in Math 1c. So 8m is less than minus 31. Oh, sorry, this is minus 31. So I forgot, so 81 minus 112 is minus 31. So when I move it to the other side, it becomes positive. So m should be less than 31 over 8. So that's the answer. Okay, so m should be less than 31 over 8. Of course, if you want, you can put it in decimal points because this is an exact value, but m less than 31 over 8 is the acceptable answer. So what I will just type here, m is less than 31 over 8. And that is the answer to this problem. Okay, so I hope that the video was useful for you. Until the next video, be safe and goodbye. Thank you.